Okay, we're back at it. So all we're doing is definitions, so the first part of this is just definitions. So now we're talking about a min value is a parabola that opens up. That means A is greater than 0 or positive. A maximum value means parabola opens down, A is negative. The min or max value is always the y value of the vertex. What is the vertex? It's h comma k, or x is h, the x coordinate of the vertex. How do you find that? You can go x is negative b over 2a. How do you find k? You plug that into the function f of negative b over 2a. So if you plug the x coordinate of the vertex back into the quadratic function, you get the y coordinate of the vertex. That's what they're telling you. Now this is the next important point. Right here. Last year, they told you that the standard form of a quadratic equation was f of x is ax squared plus bx plus c, not in this book. The standard form of a quadratic equation is a quantity x minus h squared plus k. That's called vertex form last year, but they call this standard form in this book. If you don't read your book, you're going to get in trouble. So, quadratic function given by f of x is a x minus h squared plus k, where a does not equal 0, is called standard form. The graph of f is a parabola whose axis is the vertical line x is h, and whose vertex is hk. If a is greater than 0, the parabola opens up. That means it has a min value at the y coordinate of the vertex. If a is less than 0, means a is negative, it opens down. That means it has a maximum value, which is the y coordinate of the vertex. You have to know how to do that reading. Completing the square, when I do the first problems, I'll show you how to do that. The last thing they have in definition form is min-max values. So this is mathematical jargon. You have to know how to read it. Finding a min or max value. What they're telling you is if you take a quadratic equation, complete the square, you get that. The vertex is what makes that 0, x plus b over 2a. So it's negative b over 2a. To get the y coordinate of the vertex, you have to take the x coordinate, plug it back into the quadratic, which gives you the y coordinate of the vertex. So what they're telling you, f of negative b over 2a, plug it in there, that gives you the y value. That's mathematical jargon. You have to know how to read that. So, they're telling you, here's a quadratic equation. The vertex is negative b over 2a. F of negative b over 2a, and that means f of x, you're plugging it in there, which gives you the y coordinate. If a is greater than 0, it has a min value. Where does it occur? When x is negative b over 2a. What is it? It's the y coordinate of the vertex. When you plug in negative b over 2a into the parabola, that gives you that value. If a is less than 0, again, this is mathematical jargon, has a max at x is negative b over 2a. That's the value at x where you find the y coordinate of the vertex. Once you know the x coordinate, you plug it into the function. That's what that notation is. Gives you the y coordinate, which is called the max value. Remember, the y is always the min or max value. The x produces it. That's what they're telling you in the book. Those are your notes. It's example time. I hope that made sense to you all. Now I'll try to make it simplistic and real for you. Okay? You ready? Look at all these papers I got flying around. It says sketch the graph of f of x is x squared and g of x is negative 1/2 x squared. This should be pretty straightforward for you, and that's what I want to do for you. Okay? Okay, boys and girls, we're on our way. First thing I would do is a table of values in x and y. So I create a t-chart. So, but before I even do that, I write y equals ax squared. Because once I know that, I know the vertex is always at 0, 0. And the axis of symmetry is x equals h, which in this case would be x is 0. So you should know all that right before you even start. This y right here is what they call f of x. So when you see f of x, it's nothing more than y. Got all that? That's jargon. Well, let's go. So I'm going to do my first one in purple. X, f of x. No, it doesn't say y anymore. And I just plug in -2, -1, 0, 1, and 2. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared 1. 2 squared 4. So I find -2, 4. -1, 1. Or, excuse me, 1, 1. That was 2, 4, 1, 1. 0, 0. Now -1 is 1. And -2 is 4. You know, we have this nice little line. It goes like that. There's your little parabola, and it's beautifully done. See that? This line right here in the middle is x equals 0. That's called your axis of symmetry.
Mr. Carroll, wouldn't -1 also be 1?
I got it right there. See -1, 1?
You wrote the other. You wrote -1 on the...
Oh, 1. Oh, yeah, I got you. Thank you. You know, just trying to catch up here. Now, what you have to do whenever you do a problem like this, you say, what's the vertex? Then you have to say the axis. Then you have to say the domain. Then you have to say the range. You want to know if it's even, odd, or neither. You want to know where it's reflected. You want to know where it's increasing, where it's decreasing, where it's constant. This is what you do when you do any problem now. Anybody tell me a vertex?
0, 0.
0, 0.
Axis? Axis? That's that pink line.
0.
Yeah, but you got to say it goes through the x-axis at 0, so it's x equals 0. If you just write 0, it's going to be marked wrong. So note that. That's called the axis of symmetry. What's the domain?
Negative. Your positive infinity.
That's correct. What's the range?
0 to positive infinity.
And what do we put on 0?
A bracket.
There you go. Now you're catching on. Now reflected over what axis?
The x. Or the y.
Yeah. See, that's the y. So it's reflected over the y-axis. If it's reflected over the y-axis, is it even, odd, or neither?
The x values are odd.
X values are not odd. It's reflected over the what axis there? The y. So it's called what? Oh,
Odd.
No, dear. It's an even function because it's reflected over the y. You have to know that for your test. You better know this stuff. If it's rotated about the origin, it would be odd. If it's reflected over the x, it's neither. Where's the function increasing?
0 to positive infinity.
Yeah, you're right there, buddy. See, that's INC right there. You're using the y values. It's 0 to infinity. We use parentheses there. Where's it decreasing?
Negative infinity to 0.
And where is it constant? It's not.
Okay.
I'll help you out. Now we're going to the next problem. We'll do this one in, I think, black. We want to do the same thing. Table, x and y. Negative, oh geez. I'd do -2, 0, 2. I'm not using 1 because I get a fraction, so I'd probably use -4 and +4. If I take 0 squared times -1/2, I get 0. If I take 2 squared is 4 times -1/2 is -2. If I take 4 squared, it's 16 times negative half is negative 8. Since there's symmetry, I know when I put in negative 2, I get 4 times negative half is negative 2. Take negative 4, square it, I get 16 times negative half is negative 8. Now we'll draw this graph. We have 0, 0. We got 2, negative 2. We got 1, 2, 3, 4. Negative 8 is down here. Negative 2 is 2 right there. 3, 4. Negative 8 is down here. And I draw my graph like so. And there we have it. Then we do the same thing again. We want to know what the vertex is. We want to know the axis. We want to know the domain. We want to know the range. We want to know where it's reflected. Where it's increasing. Where it's decreasing. And where it's constant. That's what you should be asking yourself every time you do a problem. What's the vertex? Can't hear you.
0, 0.
Axis?
It goes through the x.
What's
So x equals 0.
It's x equals 0. Yes. Domain?
Negative infinity to positive infinity.
Range?
0 to negative infinity, or negative infinity to 0.
Always the smaller number first. Negative infinity to 0, and 0 has a what?
A bracket.
Yeah, you better have a bracket there. Reflected over what axis?
The y-axis.
That means it's a what?
Even.
Where's it increasing?
Negative infinity to 0.
It's negative infinity to 0. Where's it decreasing?
0 to negative infinity.
0 to what infinity?
Positive infinity.
Infinity is over here, so it's positive infinity. You're reading the x-axis, and it's not constant. So they want you to describe, it says, now sketch and compare the graphs x squared to negative a half x squared. What's happening? How'd you get from 1x squared to negative a half x squared? You should be able to tell me that in a second.
It's a horizontal shrink.
No. You're not plugging in the negative half into x. It's outside. So what do you say? Anybody?
Vertical shrink.
Vertical shrink. Factor or magnitude of what? Magnitude?
1/2.
A half. And what's the negative? Magnitude. What does the half do?
The y, or the x-axis.
Reflected over x-axis. That's what's going on there. So the first thing I do is told you to describe each graph separately, and then said compare that graph to that graph. And that's exactly what happened. So there you go.
Mr. Carroll,
Yes, dear.
for the increasing and decreasing, why do you not put a bracket around 0?
Because this is a continuous function right here, because it doesn't have a distinct stopping point, we just use parentheses.
Okay, thank you.
Okay? Now, where it says what's the range, we know it has a distinct starting point right there. So that's why we have the bracket there. Because each graph is separated at that point. Now here comes the issue now, completing the square. I get tired of doing this stuff every year, but I will do it with you because I'm just like nice. To complete the square, these are the steps you would follow. I'll point them out to you. I did them to the last class. You're supposed to change f of x to y. Subtract the c constant. So that's the first step I'll do. The next step is if a is 1, we're going to skip that step. But if a is not 1, you have to factor out the a. So you wanted this video on tape so you can watch it later. You take a half of the b term, which gives you b over 2, square it, add it to both sides. This is a dangerous step. Most of you get it wrong. I'll point it out to you when I do the problem. Simplify, factor, and find the vertex. We're going to do all that, and then we'll have to stop, and then we'll finish the other one up on Monday. All right, here we go. First thing I'm going to do is take 2x squared minus 8x plus 6, change the f of x to y. Then I'm going to subtract the 6. So I get y minus 6 equals 2x squared minus 8x. Then I'm going to factor out a 2. Y minus 6 equals 2. This is x squared minus 4x. Once I've done that, I write out this step all the time. Most kids don't. They get it wrong. So you take a half of the b term. b is negative 4 there, so take a half of negative 4. That gives you negative 2. You square it, what do you get? Anybody?
4.
Now, I'm going to write up here, danger! This is where you all screw up right here. You have to add 4 to both sides. So I go y minus 6. I leave a space. I get 2 x squared minus 4x plus 4. What do I add to the other side? What do I add?
Add 4.
No.
Add 8.
See that yellow? That's a 2. In front of the parenthesis means multiply it by the 4, which means you're adding 8. The young man, you're correct.
Let's go.
Huh?
I said, let's go.
Yeah, we're going. Negative 6 plus 8. That's y plus 2. Equals. That's 2, quantity, x. You can factor this now right here, this x squared minus 4x plus 4. If you factor it, if you write out the step above, it always factors into that part right there before you square it. So it's x minus 2. You should get in the habit of writing out that step. If you don't, you're going to have